Hi, this is a webinar recorded to give you an overview of software-defined networking. Excuse me. Why are we here? Not a philosophical question, just more around sort of, how have we ended up here, I suppose maybe is a better way of phrasing the question, with regards to, the traditional networking approach of core switches, distribution switches, and access switches, maybe from a LAN infrastructure perspective. And how have we started even this conversation around software-defined networking? Well, there's been a lot of, I suppose, information and in part even misinformation in the news and in the market around what exactly is SDN, software-defined networking. Even one of the first writers that developed the thesis in Stanford University back in, I think it was 2005, has even come out publicly and sort of said he doesn't even actually really understand what software-defined networking is anymore as well, having moved on from what the first thesis was about. Today, what we're going to go through is, a little bit about sort of what the initial software-defined networking concept was, and how it's evolved, and also what Cisco are doing in the market around software-defined networking. So again, this just sort of reiterates the point around sort of software-defined networking. There's many definitions or parts of software-defined networking, such as Openflow. Some people think, that Openflow is software-defined networking. It's only actually one part of it. Likewise, is it a controller? Is it OpenStack? Is it overlays, network virtualization, etc.? What actually is really the sum of all those parts is really what makes up software-defined network, and hopefully we'll try and explain that to you today. So first, a quick level set. Just really want to sort of just talk about what is a piece of networking equipment today? What does it look like, and how does it operate at a very, very high level? So the first point is pretty much every networking device is made up of two key functions. A control plane, which primary function is basically to, I suppose, to calculate or to decide what happens with information that it receives in, and then or packets that it receives in, and what it's going to do with those packets, shipping them out, or dropping them, or queuing them, shaping them, whatever it happens to be. It's the piece of software. It's typically run in the switch CPU, and it's the bit that makes the decisions about what to do with traffic coming in and out of that particular piece of networking hardware. The plane then is usually performed in dedicated ASICs, as we call them. And an ASIC is a piece of hardware that's specifically designed to do a particular task. And it does it at very, very fast speeds because it's the hardware. Generally speaking, software on a CPU is slower than, say, a piece of hardware designed for that specific task. But it receives instructions from the control plane, and then the packets are forwarded through those ASICs, through the data plane, from port 1 to port 3, for instance, or something along those lines, and it's shipped out and forwarded on. So that's pretty much at a very, very high level. Every single piece of networking equipment operates like this today. So what is SDN, software-defined networking? Well, if we got, say, Wikipedia, it believes it's the definition. SDN is a network design concept in which network control plane is centrally accessible through an API to administrators or users of the actual network. So the first thing, basically, what it's saying is it's opening up the control plane. And what that means, basically, I suppose, is that now we can interact from maybe other applications, other management systems, or either take in some external piece of information and take that into the control plane. And on the basis of that information, maybe we can make different types of decisions about how we actually handle traffic on the actual network. So we'll talk about that a little bit more in a few moments. One instance of SDN, what was also defined was this decoupling of the actual control plane from the actual data plane. So we can example maybe where we've got a network, and throughout the network we've got maybe a couple more switches, and we've got a number of 20 maybe let's say access switches dotted around a number of wiring closets in a building on a few different floors. And traditionally in that model, each of those individual switches would have a control plane and also a data plane function within those devices. So one of the concepts within software-defined networking is we remove the control plane from each of those 20 switches. And literally, in a dedicated piece of hardware sitting in the core of the network, and it becomes the control plane for all those devices. And by decoupling the control plane from the actual data plane itself. What is Openflow? So Openflow, again, using the Wikipedia definition, Openflow is a communications protocol that gives access to the forwarding plane of a network switch or router over the actual network. Suppose going back to what we talked about there a few moments ago, this decoupling, removing the control plane from each of the devices and centrally locating it. So obviously, once we do that, we need some mechanism by which the can communicate down to the actual data plane that actually resides obviously within the switch or those 20 switches. And that protocol has been defined as being Openflow protocol. There's three parts to the story. So the first thing that you have to do is obviously the controller itself needs to be able to speak that language. So it needs to be an Openflow controller. And also then obviously we have the definition of the actual protocol that we speak from that controller down to the Openflow switch. And the switch needs to be able to understand that language and be able to translate that then into forward instructions for the actual data plane. So we have a little bit more depth. If we the Openflow switch, first of all, you'll have inside there obviously the data plane, and then we'll have an Openflow agent. Essentially, the agent is a piece of software that's going to reside within the actual switch itself, and it's able to interpret those instructions received from the controller over the Openflow protocol and carry out those instructions within the actual data plane. If we then at the actual controller itself, this Openflow controller, it's made up of a couple of key aspects. One obviously is the control plane itself. This is the piece of software that we've removed from the switches and put back onto this controller. On top of that, then we have an Openflow API, and on top of that is the applications or other applications that can interface now into that control plane. So this is what we talked about briefly earlier on in terms of taking that external information. We've got a number of APIs, RESTful APIs, Openflow APIs, to be able to communicate into the control plane. And we'll see some maybe examples of potentially how this could help simplify operations on the actual network, on the networks today. So just in terms of, the protocol is obviously evolving. At the moment, 1.0 was originally released a good number of months ago at stage. It was very much layer 2 focused. Then we had 1.1, which basically brought in multiple tables, MPLS, multicast, fast failover. 1.2 is roughly where we are today. In terms of Mac and other, you can see them there yourself on the slides. Obviously that's going to evolve over time, bringing more functionality from the actual control plane and opening that basically to be able to communicate those instructions down to the actual Openflow agent in the actual devices. So who's doing what and where do they fit into the Openflow picture? Well, the first thing I suppose what we're doing, we're rolling out a Openflow agent and indeed some additional stuff which we'll talk about in a few moments on the vast majority of our networking equipment. So it's on our ISRs today, it's on some of our switches today, and there's a roadmap to basically put an Openflow agent into and a Cisco 1PK API into, which is kind of our version of Openflow, I suppose, which is going to be installed on pretty much every single piece of networking device over a period of time. Obviously then there's the Openflow protocol itself, and actually we're currently in development of a controller as well. This will be called the APIC EM Enterprise module. There will be a DC variant of it as well, which will be used to specifically be able to control enterprise devices for enterprise customers. So we'll talk about that again in a little while too. Customers actually asking this for. So what we've discussed so far really is just the sort of the basic concepts of what SDN is. This decoupling of the control and data plane, that centrally located controller which takes over the function of the control plane, and then opening up that control plane through APIs to external applications so that we can actually make the network more efficient, make it easier to operate, and make it more dynamic as well for applications that request services of the actual network itself. But what exactly are customers actually asking us forward in terms of using SDN in anger on networks? Well, we need to sort of probably look at different types of customers, I suppose. We look at maybe, say, hosted data centers. They're very much interested excuse me, in multi-tenancy and scaling the consistency across physical and virtual resources. You know, in large hosted data centers, they want to virtualize that infrastructure. They want to see if SDN can help them in maintaining and operating that virtualization infrastructure across whether it be virtualization of servers to virtualization of the network infrastructure itself. And we'll touch that in a few moments. In terms of Web 2.0 or managed services data centers, we all need programmable. They're looking for maybe programmable APIs, and then you can leave the rest to us. So what they want is basically to open up the controller, open up the network through those APIs, and then they can actually then feed information to make decisions on the network through that. For education, academia, want Openflow to play with, and then, we know it's not ready, but we may want to pursue research ideas. So, there's an awful lot of developments, I suppose, within customers today, and want to have a look at what Openflow could potentially mean. I suppose one key point around SDN in general is really that actually it's still a developing technology. And the market is still trying to come to terms with how best to use this technology for business purposes. So what are the options to meet these demands? Because there's a number of key different types of demands there. One is, Openflow, the protocol. Two, opening up the APIs. And three, virtualization of the actual network as well. So those thoughts on SDN is basically to sort of have a very broad view or a broad portfolio maybe across those different areas, and working to try to develop solutions for our customers in all these types of areas. So first and foremost, we're working in the area of network overlay virtualization. So this is the idea where we can actually virtualize the network as well using SDN, and I'll touch on that in a little bit more detail in a few moments. Another approach is to have programmatic device APIs, so the ability to directly program through these APIs the actual network infrastructure through external applications. Well, one key aspect is actually network abstraction. What I mean by this abstraction is to sort of remove the complexity from networks. Networks today are getting more and more complex, and the amount of features that are in switches today across multiple vendors it can be very, very complex, and sometimes then maybe too complex, and in certain ways then maybe not all features are enabled on certain switches, when actually there's some very good, unique features that you can take advantage of and implement and actually have a business benefit. Quality service, even at a very basic level, can be quite complex to actually configure for multiple applications, especially we move with media-rich applications, also with applications moving to cloud and virtualization, even complicates that even further. So if there's a way that we can sort of abstract the complexity, but still have the ability to actually maintain the functionality on the actual network, would definitely be a major benefit for day-to-day operations and cost savings within the IT departments in your networks. One of the key things is to develop SDN and the applications around SDN. We really need to take this sort of real agile mechanism by which of actually developing this software, and that's to be able to sort of, rather than sort of going, yes, we're going to develop a product, find out a set of resources, and then try and implement that. We really need to come at it from a sort of a different perspective and actually develop it, sort of go, this is what we're actually going to develop, and then work out how to do that. And also, be very flexible in how we take feedback and actually develop the program over time, and to maybe even the ability to actually request features from our customers, and sort of really taking that open source model nearly to some degree in terms of feedback and actually development of features within the actual software as well. So network overlay virtualization. It's about the virtual networks and virtual and physical devices. It's being able to say, okay, I have this large bank of compute here, I'm going to run a number of VMs on it, and they're all these physical hosts are all connected obviously into switching infrastructure, but what I want to be, and then obviously that's the switching infrastructure being connected into maybe even routers and WAN circuits, and I want to be able to actually virtualize each of those network components for maybe a particular customer. So, as data centers grow, usually for a customer, they want layer 2 connectivity between a number of VMs, but as data centers grow and grow and grow and expand, maybe that's not particularly feasible. So network overlay virtualization gives us the ability to virtualize the physical infrastructure into components for individual customers, and all they see and have fine-grained control is of the actual network that's been virtualized for them. So it's obviously absolutely key to, obviously the first thing is we can allocate resources on demand, but it's absolutely key to multi-tenants within MSDCs. Programmatic device APIs then gives us sort of programmatical control of the actual device. And really what we're talking about here is being able to tie in the orchestration and management systems, and indeed actually the applications through that API directly into the actual control plane. Excuse me. So again, this allows us to sort of take external information and to be able to feed that into maybe the routing decision, for instance. And I'll show you an example of maybe that in a few moments. For the actual routing of traffic across the actual network from this external application. The network functional abstraction will allow us to basically sort of have external applications being able to talk down to the control functions of the actual controller, and that controller talking down to the actual data plane. But to have that layer of abstraction, basically. So, you don't need to know how to configure a quality of service policy for voice, video, the important applications or other real-time applications, and then best effort queues, etc., etc. You don't need to know the commands and so on to be able to configure that. All you need to know is that this person wants to use this application, they have logged into the actual network, and the application requests the types of resources from the network to be able to operate that application correctly and to use the right experience on the network. For that application to request those resources directly of the controller, and then the controller to be able to actually carry out and implement the right quality of service policy underneath that. It's about what we actually want to do, and not so much about the how anymore. It's about what we actually want to achieve for that particular user or that particular application on the actual network. We could use this also not just for quality of service, but maybe for path selection. We could also use it for network policy in terms of security, and also maybe to safeguard ourselves against denial of service attacks or malicious traffic on the actual network. So there's lots of different ways that we could actually use this technology for simplifying network, but actually still increasing the usability and the security of actual networks as well. Just a couple of simple use cases, maybe just to sort of help you understand what we've been talking about. So this is one particular example, an enterprise-wide network tap. Customer needs packet-level visibility into any point of the network. And in the past, maybe if we're looking at maybe say site X here, for instance, in the past maybe what you would have had to do is if there was a problem in that particular site, and it wasn't sort of that the site was down, they were having intermittent issues or something along those lines, you might have had to send somebody out there with a network analysis tool, which is a piece of costly equipment. Took time obviously to get the person down to that location, plug it into the network and start sniffing traffic on it, and then analyze it whilst you're down there. We're actually now with SDN, what we can do is we can actually request that remote location to actually send traffic up to the actual core location where we can analyze it from there. So I know it's a low-level example, but it just shows you the simplicity by which we can actually request traffic and have finer-grained control of the actual network itself. Use case 2, maybe routing override or route selection, path selection. And what I'm trying to show in this particular example here is over the left-hand side, you've got sort of the primary path back to the data center. And this is a remote location. They're using voice, video, there's data clients. And we also have a secondary path. And typically in most sort of networks today, all traffic goes over the primary path, and then the secondary path is not used unless the primary path fails. But obviously, as we roll out more and more applications and applications become far more media rich, they're using more and more bandwidth. And hence, in this scenario, we'd have to upgrade the pricing, and obviously that's a costly approach. So one of the options is to sort of go, well, actually, what I'm going to do is when a user, in this particular example, we're talking about connected backup, which is basically a backup of maybe a PC and all the software on it, or files on it, if I say more accurately. When the connected backup kicks off, what we're going to do is we're going to put a route into the actual remote location that's actually the path I want you to take for this particular application is over the secondary link. So now all other traffic will go via the primary, the business applications, etc., but the connected backup is going over the secondary path, and therefore we're saving on the bandwidth that would normally be in place for that particular application. However, what we can also do is sort of go, well, actually, if primary link fails for whatever reason, and then my business applications need to go over the secondary path, I'm actually going to stop that connected backup from happening for the period of time that the primary link is out. And when it comes back up again, obviously the business applications go back across the primary and carry on then with the connected backup to the storage and wherever it happens to be in the data center. A good example of sort of how we're taking information in from external applications, push it down through an API into the controller, and then using that information to make a routing decision, for instance, on the actual network. So what is Cisco's overall SDN strategy? I suppose it's really quite a comprehensive portfolio in that we're looking at different areas. We're not just basically saying, okay, we're going to support Openflow and that's it, we're done. We're actually doing a number of things, and we're actually absolutely going to support Openflow, and it's already there in some of our networking equipment today. We're also looking at this 1PK API as well that we're putting into our switches, and this will give us a lot more features and functionality through that API for that programmability within the actual network, and being able to facilitate that abstraction as well for simplified configuration of the network, on demand automation and orchestration of the actual network as well. So we're absolutely supporting the standards, and even to the point that we're part of the Open Foundation. We're a platinum partner there. So what that essentially means is we're actually funding the development of an open source controller as well that will be free of charge. We've given code towards that, and we're also giving funds towards that as well. So we're supporting both the open source path in terms of development of controllers, and obviously our own internal controller, which we'll come on to in a few moments. We're also supporting virtual overlays as well through virtualization of our technologies, of our switching environment, and through the use of VXLAN and VXLAN gateways as well, to virtualize that infrastructure and make it more easier to virtualize not just the actual compute, but the actual underlying physical infrastructures as well for multi-tenancy applications as well. Basically talk about one thing that will be coming out over the next year, during this year, which is our APIC Enterprise module. So this is our software-based controller, and it's going to clearly be focused on the network abstraction and automation. And it's going to be software or an appliance based. We'll absolutely have all these open data, open foundation or open data, APIs, RESTful APIs. It will support Openflow and 1PK as well for talking directly to Cisco equipment. But obviously with Openflow, you can talk to any equipment that supports Openflow as well. One of the real important points around our strategy is it's not a rip and replace. There's going to be Openflow, 1PK is going to be in all our existing platforms over a period of time in terms of all our Catalyst switching portfolio, our ISO and our ASO routers as well, and indeed our Nexus portfolio too. Obviously, as I said, we briefly mentioned this earlier on around the agile integration. We want to take that real flexible approach to developing the software. Feedback from customers is absolutely key in terms of new feature requests and so on, and getting them as quickly as possible into this particular enterprise module as well for this controller. So some specifics just around how that's actually going to look. What it's going to mean basically is we'll be able to take Cisco and third-party applications using that REST API into the APIC EM module. And through that, the first three that we're actually going to focus on for our first three applications is actually going to be around security, also around quality of service, and mobility basically on the actual network, because we see those as three key things within networks today. And with all the advent of video, cloud, and mobility of users and devices on the network, and mobility of applications on the network, networks are becoming far more complex. And what we're really trying to do with the APIC EM is remove that complexity complexity from the actual network through that abstraction layer, which is the controller, and then being able to directly then interpret those instructions and configure the actual network, the underlying network, through CLI, through Openflow, through 1PK API down to the actual devices themselves. These are the first three applications that we're actually going to be having within the APIC EM. We'll have network-wide rapid threat detection and mitigation through our source fire. So as we actually see traffic on the actual network, we can report that back and then feed that up into external applications to actually implement security, block that traffic, for instance. We'll also be able to do ACL management. So ACLs can grow very, very quickly if you start implementing ACLs for security reasons and for quality of service reasons, to identify traffic on the actual network, or to block it, or to treat it in a certain way through either policy routing, for instance. A lot of ACLs can become very, very complex very, very quickly. So, one of the things that we're building into the APIC EM is the ability to automate those ACLs, or the management of those ACLs, so that it still exists on the equipment, but we're going to abstract that complexity within the ACLs from the actual user, or from the IT person, if I say it more accurately. Same type of theory, but applied to quality of service provisioning. Make it easy to actually deploy quality of service. Make it easy to actually deploy, but also make it easy to sort of to follow the user as they move around the actual network. Because I mentioned earlier on, mobility is one of the key aspects that we see in networks today. And as mobility happens, then the ACLs and the quality of service parameters become even more complex. Excuse me. So that quality of service policy needs to follow the user on the network. So we have some way of identifying the users on the network, then we can absolutely use SDN and the enterprise module, the APIC EM, to actually ensure that we, as the user moves around, that we actually map that quality of service to those. And obviously, if we're going to remove the complexity from the network, and you're going to sort of trust this device to actually configure those rules on your behalf of your request, or the applications requesting those services, well, then we also need to build in what we call sort of like a trust me model as well, or show me model. Because if you trust somebody, you also want to be able to see what's actually happening. So one of the aspects as well is the ability to say to the controller, well, show me what's actually happening on the actual network today, and it then to actually pull that information from the network and to give that back to you in a graphical format, so that you actually see what's actually happening. One of the other things, obviously, we're going to do as well is around the is path optimization. So going back, if you think back to that example earlier on, my apologies, earlier on of selecting routes based on maybe applications requesting certain resources on the network as well. Some of the applications that's going to take advantage of the actual APIC EM when it's released. Just to sort of recap, this is the last slide I have for this presentation. This is our one network environment. As I say, it's quite a broad approach to SDN. I think SDN really just sits in the middle there in terms of that decoupling, having that controller coupled from the actual data plane. But we're concentrating too on programmatic APIs, and also virtualization of the actual network. And certainly we believe that we have quite a good strategy that hopefully meets the needs of all our customers. So thank you very much for taking the time to listen to this recording, and hopefully it was of some benefit to you.